today's our first problem is happy number. Okay, then what the problem says? The problem says that requires us to determine if a number is happy. A happy number follows the process. Okay, the happy number is replace the number with the sum of squares of its digit. Repeat the process until we reach 1. If reach 1 is happy number or enter a cycle, actually, so this is not a happy number. If we reach 1, then it's written true, otherwise it's returns false. So the approach we follow, the step by step, is we solve using while loop and a set to track the visited number. So step 1, use a set to track visited number. Since a unhappy numbers from a cycle, we use a set and track a number we have already seen. If we seen the same number again, we know there is a loop and it returns false. Extra digit and compute the sum of squares. Then we extract each digit using the modulus of %10 and operation and compute the sum of squares. After processing all digits, we update n and then we with this sum and continue the process. The work then like n equal to 9. Okay, let's n equal to 9. First iteration n equal to 9, digits 1 9, sum of square 1 square plus 9 square, then it is equal to 1 plus 81 equal to 82. Then update n equal to 82. Second iteration it would be n equal to 82, then 8 and 2, sum of squares 8 square plus 2 square equal to 64 plus 4 equal to 68. Then update n equal to 68 and continue with until we reach 1 or cycle is detected. So our code, then we started coding. Okay, last we have a definition class and def is happy. Okay, our function is happy. Then we have to take a variable. Let's take a variable name visited numbers. Okay, let's take it set. Thus we store the numbers we have seen, and then we do a while loop. If n equal to 1, then we return true. If we reach 1, it's a happy number here. And if n visited number return false. So cycle detected and it is not a happy number. Then we have to do, then we visited numbers. Then marks this number as seen. Then take a variable squares, sum of squares equal to take variable it's 0. Then current number, then we take a while loop, while current number. Then what I do, divided 10, it gets it gets the last digit. Then sum of squares plus equal to digit. Here we do 2. So here squares and add it current number 10. So remove the last digit and equal to sum of squares. Okay, let's run it. Okay, it's okay. So we use a set to detect cycle and a loop to compute the sum of squares of digit. Then the solution efficiently detects the happy number O, and the time complexity would be here. We use this time complexity. Each steps reduce n by breaking it into digit, so which is roughly O log n operation. And space complexity here is O log n. We store visited number in a set which takes a space proportional to the number of unique numbers before a cycle forms. So it's a O log n space complexity and time complexity O log n here. And I think it would be a happy number, a number that when replaced by the sum of squares of its digit, eventually it reaches 1. If a number falls into a cycle never reaches 1, it is not happy number. To detect cycles, we use a set to track sin numbers. If we see a repeated numbers, we return false because it means we are stuck in a loop. So it is the problem, and it is okay. Thank you.